This is test number 6, study guide, sections 1-1 to 7-3. This is part 3, starting at number 15 or picking up on 15. The sum of two numbers is 76. The difference is 16. Write a system and then find the two numbers using elimination. Well, we have the sum of two numbers. So sum we know means to add. So if we have one number we don't know, we'll call it x, plus a different number we don't know, we'll call it y, equals 76, because that's what it told us the sum was. The other equation says that it's the difference. It's 16. So the same two numbers, we don't know what x is, minus now, because we're talking about difference, we don't know what y is 16. So we have two equations, x plus y equals 76 and x minus y equals 16. And probably the toughest part is writing the system. Again, sum means to add them, difference means to subtract them. Notice they're all stacked on top of each other in the right spots. X is on top of x's, y is on top of y's, constants on top of constants. And you have opposite terms, y and negative y. So we can combine these and eliminate them. When you combine x and x, you get 2x. When you combine y and negative y, you get 0 y's, or you eliminate the y's. And when you combine 76 and 16, you get 92. So 2x equals 92. In order for you to get what x is, you divide by 2. Do the same thing on the other side, and x equals 46. So x equals 46. In order for you to find out what y is, take one of your equations and plug in the value of x. So if we take the first equation as we have it written, x plus y equals 76, plug in the new value of x. We have 46 as it, so 46 plus y equals 76. Subtract 46 to get rid of it, minus 46. Do the same thing on this side, and y equals 30. Y equals 30. So it says the sum of two numbers is 76. When you add up 46 and 30, you get 76. And their difference is 16. When you subtract 46 minus 30, it's 16. So your numbers in this case would be 46 and 30. 46 and 30. Number 16, it says Sharon has some $1 bills and some $5 bills. She has 14 bills, and the value of everything is $30. Write a system finding out how much of each kind of bill she has. Okay, you can use O for 1 and F for 5, but O's get really confusing. So let's say $1 bills, let's call them X. And $5 bills, let's call those Y, just to where we don't get confused. So we have X and Y. Now we have some amount of $5 bills and $1 bills. So if it says she has 14 bills, the amount of X plus the amount of Y equals 14. We don't know how much of either one there is, but we know that if we put the two types of bills, we put everything together, if we add them up, we're going to have 14 bills. That's one equation. The other one says the value of the bills is $30. Well, we know that a $1 bill is 1 times X. So the value is 1 times however many $1 bills we got, plus the value of a $5 bill is 5 times however many $5 bills we have. And we know their value is $30. So this is the toughest part, writing the equations. These are the two equations you're going to want to use. Again, X plus Y, you don't know how many of either the bill it is, but they equal 14 bills. And you know that their values are $1 for the $1 bills and $5 for the $5 bills. So 1 times X plus 5 times Y gives you the total value of 30. Now you can use either way either method you'd like for this. We have x on top of x or 1x on top of 1x. So it's probably easiest to use elimination or combination, as we would call it. But we need to make one of them an opposite term. So if you take this entire first equation and you multiply it by -1, it'll give us opposite terms. -1 times x leaves you with -x. -1 times y leaves you with -y, and -1 times 14 leaves you with -14. So now you have two equations stacked on top of each other properly with opposite terms. When you combine these now, x minus x leaves you with 0 x's. That's what we did. We eliminated them by combining them. That's what we were aiming to do. 5y minus 1y is 4y. And 30 minus 14 is 16. So now to get however many y's we got, we divide by 4. Do the same here. And y is 4. So if y is 4, we know our $5 bills were y. So the $5 bills, there are 4 of them. In order to find out how many $1 bills we got, we just have to take one of the equations. If we look at that first one, x plus y equals 14, and we plug in however many we got for x, we know for y, we just found the value of y. It's 4. So plug in the number 4 in place of y. So get rid of x plus y by subtracting 4 on both sides, and x's value is 10. So your $5 bills was 4 of them, and you know your $1 bills, there are 10 of them. 4 and 10. Number 17 says solve the system using elimination. Watch how fast these are going to go. They're stacked on top of each other. The x's, the y's, and the constants, and you got opposite terms. So combine them. 3x and 5x is 8x. 2y and -2y cancel each other out. 14 and 18 is 32. So 8x equals 32. Get rid of 8 times something by dividing by 8, and x equals 4. X is 4. Once you have x's value, plug it in to get y. Instead of 3x plus 2y equals 14, 3 times x plus 2y equals 14. Plug in your new x value of 4. 3 times 4 is 12 plus 2y equals 14. Get rid of positive 12 by subtracting it. Do the same on the other side. 2y equals 2. Get rid of 2 times something by dividing it on both sides, and y equals 1. So x comma y would be 4 comma 1. Number 18, x plus 5y equals -13 over 4x plus 15y equals -37. Notice we don't have any opposite terms. Our x's are over our x's. Everything's stacked correctly. Y's over y's, constants on top of constants. But we can say that 1 and 4 we can multiply by 4, or we can recognize that 5 times 3 will give us 15. So if we take that first equation and we multiply everything, not just by 3, but by -3, where we can create opposite terms. When we distribute -3 times x, we get -3x. When we distribute -3 times 5y, we get -15y. And -3 times -13 gives us -39. So we have two equations. They're stacked properly, and we have opposite terms, 15y and -15y. Again, we have two equations. They're stacked properly. Now we can combine them since we can eliminate one. 4x and -3x, when you combine those, it leaves you with just 1x. 15y and -15y, when you put those two together, you get 0y. We eliminated it. That was our goal. And when you combine 39 and -39 and -37, you get -76. So look how we have it written. We don't have anything else to do to find x. It says it right here. X equals -76. So now take that value and plug it back into whatever equation you think is the easiest one. We take that first equation, x plus 5y equals negative 13. And we plug in, instead of x, we plug in our value that we just got for x, which is negative 76. Here we have negative 76. Get rid of negative 76 by putting it on the other side. Add 76. Do the same thing to this side. 5y equals 63. I actually made a mistake. I have to go back and change it a little bit. It's not negative 76. When you multiply the top equation by negative 3, a negative times a negative is going to give you a positive. I'm sorry, negative 3 times negative 13 is going to give you a positive. So instead of having minus 39 like we had, it'll be a positive 39, and we're going to have a lot more user-friendly numbers. So instead of having x equals negative 76, now we got x equals 2. Look how big of a difference that was, something small like that. X equals 2. And instead of plugging in negative 76, now in place of x, we plug it in 2. This makes it much more user-friendly. Get rid of positive or plus 2 by subtracting it. Do the same here. 5y equals negative 15. Get rid of 5 times something by dividing by 5. Do the same here, and y equals negative 3. So you have two values, x and y. X comma y is 2 comma negative 3. That's the point where those two equations will cross each other. That's your ordered pair, 2, negative 3. Number 19, you have to find the least common multiple for. Actually, we'll pick up number 19 on the next video.